So for lesson 2.6, the last of the chapter, our test will be next week. We are going to work backwards from what we did last week, where last week we had a value and the mean and the standard deviation, and we wanted to know the proportion or the percentile or the percentage. Now, if I know the percentile or the proportion, I can work backwards to find the value that is that percentile. Also, what if what is the standard deviation or the mean? We can solve for those as well. All centered around our z-score equation, x minus the mu, the mean, divided by the standard deviation. So, remember, we're back to this Gary, Indiana test scores, right? Over and over again, the same examples, but we can use this. Our distribution was normal, right? With the mean of 6.84 and a standard deviation of 1.55. What score would a student have to earn to be at the 90th percentile of the distribution? Okay, so we're going to want to write this. We're going to copy this info again. Normal with the mean and standard deviation, and then what score is the 90th percentile? That's the only thing that's really important to write down. Remember, we're normal, 6.84, comma 1.55. So on the picture, we see that 90th percentile's got to be somewhere between positive 1 standard deviation and 1 standard deviation. Or, I'm sorry, 2 standard deviations. So we're going to reverse the process that we used in the last section. All right, so remember last week, we ended our problem by possibly looking at a table to find the proportion, right? Ultimately, we used our calculator, but I do want to show you how to use the table first, and then we'll probably never look at the table again. But we want to look for values inside the table that are closest to 90%. How close can we get to 90%? All right, guys, so where do you see 90? Right in between here. So the percentage, what z-scores will give me a percentage close to 90. 0.8997, that's pretty darn close, right? So is 0.9015. So if I go, this is my hundredths place, it's going to be 0.08. And if I go over, I'm at 1.2 and then 8, 1.28. Okay. 1.28 is going to be the z-score because that's the closest to 90 that I can get. I could go 285, I could go halfway between these two, right? Because I have 90.8997, 0.9015, so between there halfway might be 90 exactly, right? We're looking for the percentage that's 90 because the question was, what score is the 90th percentile? So we're working backwards from what we did last week. We have to start with the percentage. We're either going to use the table or the calculator to get a z-score. Remember, we started with the x value, we got a z-score, and then we used the z-score in the table or the calculator to get a percentage. So we're going backwards. Okay? So we said from the table 1.28, maybe 1.285. Let's look at the calculator, though. How are we going to do that on the calculator? Because let's be honest, that's how we want to do it anyways. We don't want to have to reference a table all the time. So get your calculators back out. These are going to be really important in this chapter and next chapter, right? So make sure you always have it with you. Okay, do we remember what menu the normal CDF was in? Second, vars, we're going to go to the same menu. Okay, we use normal CDF to put in the z-score and get a percentage. We're going to use inverse norm to put in a percentage and get a z-score. Okay. Second, vars. I actually would like to get the other calculator. I didn't put anything in yet. I didn't even choose it because I need to use this calculator. It's a little different. Now, no, you don't know the z-score. You want the calculator to give you a z-score. So I'm going to go to second, vars, hit enter on inverse norm. Okay, most of our calculators, if you have the 83, gives you this screen. If you have the 84, it looks like this. Okay, now what percent did it ask me for? The 90th. So we're going to put 0.9 into the calculator. And here we're going to put 0.9. I'm going to leave the mean and the standard deviation, and I'm going to select left. If you have an 84, we are going to do everything left because these calculators only do left. Okay? A percentile, remember, is 90% of the values are less than that 90, right? The less than that value. The calculator only gives you that less than. Okay, we'll talk about what to do if I didn't want the upper 10% or something and how to change that to get the right z-score out of the calculator. So for this class, we're always going to leave it on left if you are using a TI-84. And if you're using the TI-83, we always have to put in the left percentage, so the left area. And I'll show you what I mean by that in a second. So this is inverse norm. I get the same answer, 1.282. It's a little bit, right? This is the most accurate one. We were pretty close with 1.28. We said maybe 285, but it's actually 282. Okay. So we're going to start with this value. Okay. Now, our model, let's just remember what that picture looked like, had 90% of the values below. I want to know what that value is. Okay, so that's what I mean by left. The calculator only calculates from the x value you give it and below. So you have to give it the percentage below the x value you're interested in. That's going to change for some of the questions and how we find out what to plug into the calculator for that. So when I do inverse norm, okay, inverse norm gives a z-score. Okay. So it gives us a z-score based on the percentage we asked for. So for this case, the z-score for the 90th percentile is 1.282. And remember, we're talking about the Gary, Indiana vocabulary scores. It has a mean of 6.84 and a standard deviation of 1.55. So I have my z-score equation. What can I plug into that equation? The z-score, 1.282 equals 90. X. X is what I want to know. I want to know the score that represents the 90th percentile. 6.84 is my mean. Minus 6.84. And what else can I put in? 1.55 is my standard deviation. Now I'm solving an equation. Yes? Why? Because I don't know x.
Yeah, so it would be like, so you know we usually put like x, because
1.282 is a z-score. So this equals the z-score, right, that represents, this z-score represents 90%. And it doesn't matter what my mean and standard deviation are. If I want the 90th percentile, it's always going to be a z-score of 1.282. But now I want to know what score on the vocabulary test that represents, right? So the z-score, remember, is standardized, a mean of 0 and a standard deviation of 1. So 1.282 standard deviations is always going to be the 90th percentile. But what is that vocabulary score on that test that represents the 90th percentile? Okay. If you were the 90th percentile, what score did you get on that test? Okay, so then we're going to solve for x. How do I get rid of the denominator of a fraction? We multiply it by 1.55 over 1, basically, right? So that the denominator cancels. So 1.282 times 1.55. We're doing that in the calculator. You will never not be allowed your calculator. Okay, we don't expect you to do these things by hand, and we get most of our values from the calculator. And now what do I do to solve that? So we'll add 6.84. We get 8271 equals x. So a score of 8.8271 is the 90th percentile on the ITBS test. This is the score. 8.8271 is the score that represents the 90th percentile. So if you scored 8.82 on that test, you scored better than 90% of the students that took that test, right? That's what a percentile means, right? You scored better than 90% of the students in 7th grade in Gary, Indiana. Okay. So let's go talk about the stopping distance of cars again, right? Many studies on automobile safety suggest that when automobile drivers must make emergency stops, the stopping distances can be modeled by a normal distribution. Suppose that for one model of car driving at 60 miles per hour under typical conditions on dry pavement, the mean stopping distance is 165 feet with a standard deviation of 4 feet. 1% of all such emergency stops take more than what distance? So here's where it's important for us to draw what it's asking us. 1% take more than what distance? So I want...
So it'd just be more than 99%?
Yes. I want this 1%. I want to know what that x is. My calculator doesn't give me greater than, it only gives me less than. What percent of this model is less than 1%? 99%. Okay. That's what I need to ask my calculator for. I need to ask the calculator for 99%. So we're going to do inverse norm 0.99. I get 2.326. Make sure you get that from your calculator, inverse norm 0.99. So you cannot put inverse norm 0.1. 0.1 is going to give you the lower 10%. If you put 0.01, it's going to give you this 1%. I want the more than what value, right? So I need the upper 1%, which means I have to ask the calculator for the lower 99. And that's what left, center, right means if you have a TI-84. The newer calculators allow you to say, oh, I want the right percentage and put in 0.01. Okay. So remember our equation, z equals x minus mu divided by sigma, and the inverse norm gives me z. So can you plug that information in and solve for x? Go ahead and take a second and do that. Okay, so our formula, our equation should look like this. 2.326 equals x minus 165 divided by 4. You can multiply by 4 and then add the 165, and x equals 174.304 or 174.305. If you kept it unrounded in your calculator, either one is okay. Did you have a question? No? Okay. So that means that 1% of all such cars take more than 174.3 feet to stop. Okay, so it's also possible to find a mean or standard deviation of a normal distribution if I know a value and one or more percentiles. So here we have information about a 7-year-old girls. The clinical growth charts at the cdc.gov show the percentiles corresponding to different heights for children of each sex and age for 7-year-old girls. The mean, here's information, right? What are we talking about? Okay, heights of 7-year-old girls. The mean is set 48 inches. The 90th percentile is 51 inches. Assuming that the distribution of heights is approximately normal. If it's not approximately normal, we can't use any of this. It has to be approximately normal. If the data is skewed, then this is useless. We're going to find the standard deviation. So let's write down what we know. The mean is 48 inches. The 90th percentile is 51 inches. We want to find sigma. So let's start with our z-score equation. What do we know so far? Do I know the z-score? No, but I can probably find it if I know what percentile, right? Do I know what the x? Yes. 51 inches becomes my x. Because at 51 inches, that's the 90th percentile minus the mean of 48. And the standard deviation is what I want to find, right? Sometimes I think it's helpful to plug everything you know into the equation and be like, okay, what am I finding? I'm finding sigma, that's what it asked for. So what do I need? I need the standard or the z-score. What in the problem is giving me what I need to find the z-score? The 90th percentile, right? So that's again inverse norm 0.9, which is 1.282. I think we just did that 2 examples ago, right? 90th percentile. Equals 51 minus 48 over sigma.
Would you still you would do 0.9?
Yes, I would still do 0.9 because it says the 90th percentile. So that's just 1.282 equals 3 divided by sigma, right? We're going to multiply by sigma on both sides. So 1.282 sigma equals 3. And divide by 1.282. So sigma equals 3 divided by 1.282, which equals 2.34 inches. So the standard deviation for heights of 7-year-olds, girls, is 2.34 inches.